once again to day 4 of the Imtex Firming 2020 exhibition. For the past 4 days, we have seen an incredible hype in additive manufacturing. Today, we are at AMS India with Mr. Shashidhar NC, who is the CEO and director of the same. So let's go over to him and see what they have to offer us. Good morning, sir.
Morning.
Sir, can you tell us about your company and what you all are presenting at Imtex today?
Yeah, we are actually a 3D printing company and a automation company basically. Today we are presenting a storyline where we can move from scrap to reality. That's the whole thing. And we have made a few machines which can actually, we are trying to use it to convert plastic bottles, make parts out of it. And so we have made a machine which can cut plastic bottles into small powder format. And that's the machine that we have over there, which is used for making powder. And then we have another machine which can actually convert this powder into a filament, basically. And this one, we have made a 3D printing machine which can actually be used for printing this thing into different useful components. So,
Sir, can you give us a demonstration of your 3D
yeah,
printing
we can.
machine?
I just want to. So this is a machine which we have, which is going to first convert it into plastic powder. So I can just switch this machine on, and you can see over here, this actually is cutting. This is actually going to cut the plastic bottles, and they get filament or powder over here. This is the powder that comes out of plastic bottles, and this filament or this powder, basically whatever we have, is taken from this particular thing and put into this machine, which is going to convert it into a filament. So this actually extrudes the plastic, it's going to heat it, and then you get a filament out from this. So this filament basically is put in the form of a coil or a wire, wind it, and you put it on a machine over here. And on this machine, we can, this machine basically is a 3D printing machine. It's called the AMS Hyral 3D, the model is called Hydra 16AS, and AS is for small. So it's actually got a stroke of 600 millimeter in X, 400 in Y, and 250 millimeter on the Z axis. And there is an extruder over here. It's got the wire which actually comes and feeds it over there and starts printing plastic and makes parts, basically from the filament. This machine is very unique in the sense it's basically an R&D machine. And actually our company makes 3 types of machines. One is an industrial research machine, which is this one. We also make a biological research machine, and this is the biological research machine that we have over here. This is a small version of the same kind, but this machine actually is for printing scaffolds, which can be used in the medical industry. Most of the labs use it basically. So in a Petri dish, we actually print scaffolds layer by layer, and that is used for testing and culturing and to find out which disease it is very early. The medical research machine. But we are presenting here this one which for industrial research, which can be used for printing plastics. It can also be used for printing ceramics. It is also used for printing metal parts. It is for all types of plastics. And you can see all these are the different types of plastic machines, plastic parts which you have printed on the same machine over here. And this machine actually can be used for printing liquids, gels, powders, pastes, and filaments, of course. So we have a bunch of extruders that is put over there, which I can just show you. These are the different types of extruders that we have built, which works along with the machine. For example, we have these are called extruders. This extruder basically is there are 3 types. This is a stainless steel extruder that we have, and this stainless steel extruder is basically for printing corrosive type of parts like ceramics. Then we have an aluminum extruder over here. Then we also have an extruder which is syringe. It's called syringe disposable system. So you have a syringe disposing out here. And this is a mixer where you can actually mix 2 types of epoxies and print also. So epoxy is printing, and for filament printing, and for aluminum powders. And this is a powder extruder which goes along with the machine, so you can print powders for making metal parts. And we also have not only for additive manufacturing, we also have subtractive manufacturing, where you have a milling cutter out here which can be put on there, and you can do some milling or drilling and other turning operations on the machine. So both additive and subtractive. We also have a pick and place mechanism on this, so you can take apart, you can do induction heating, it's basically an R&D machine. A guy wants to design something and he wants to manufacture it. So he designs it on the desktop on his R&D lab, and immediately makes a part of it here, and then he can fit, function, test, and it's going to help R&D. And this is an R&D research machine. And along with this, we also have different attachments to the machine. We have an attachment to the machine with which you can also not only do additive manufacturing, like 3D printing, you can also do bending. So you have a plastic bending machine. So I have a plastic sheet, I have a bending machine, put it over there, it heats it and bends it. Then you have additional access to this. So this is a 3-axis machine. I have additional 4th and the 5th axis also to the same machine. So this is basically the 3D printing portion of the whole lab that we have here. Anybody who wants to do research and develop parts, prototypes, R&D. It could be educational institutions doing R&D, big companies who have an R&D product development. They want to make different new products, or if they have any part for that matter. It takes a long time for somebody to actually design a part and then make a prototype of that, take it out to some place, machine shop, and do everything. But here you can design it, immediately print it, check it out, working, not working, improve your design, optimize it, and once your R&D work is over, then you can productionize it. That's a different topic altogether. That's a big business. A different thing. But here, till the level of getting it into the manufacturing engineering stage, I think this is the best machine that we can have in the world. And actually, there is no other company in the world who's making a machine as versatile as this. This is the most versatile machine that you can do additives, subtractive, plastics, epoxies, ceramics, everything on one machine. And that's the uniqueness of our machine. We also have another thing. We also have a IoT lab set up over here. These are IoT kits, what you call a kit. Simple, small IoT kits. It's Internet of Things, what do you say? We have different sensors which are connected to this. For example, you have a digital dial indicator. This is a fundamental of measurement in any company. You have a dial indicator, right? We have connected a dial indicator to a machine, to this gateway, which is actually throwing the information on the net into a server. So we are able to get the information of dimension, a very accurate precision measurement dimension we are getting. So we can see, like we make checking fixtures. So you can see over here a similar type of a checking fixture arrangement that we have, and then you have the sensors put on the checking fixture. So a OEM company who wants to give out parts to a subcontractor can make a checking fixture, keep it at the vendor's place, and measure there just after manufacturing, and come to know at his place whether the part is okay or not. So you save time and logistics and etc. etc. So along with that, we also made process sensors, we made digital analog sensors. All these kits are basically, it's going to help almost all machines bring it to Industry 4 compliance. That is the whole objective. Convert a machine, put all these sensors on the machine, make it Industry 4 compliant. We have sensors which can sense temperature, pressure, volume, level, dimensions, analog, digital, all types of signals. We are able to capture it, send it out on the net, then you make your own dashboards and analysis and do whatever operations you want. This is what we are presenting.
Thank you so much, sir, for presenting. Thank you.